Well, I want to thank everyone for joining us today. We're super excited to kick off a new type of workshop with a series approach. This is going to be the first of three with a partnership with the Playgrounds dev team. Super excited for that. I'd posted the link to Gitbook in a couple of the workshop channels. I can do that again, and all recordings will be on there afterwards, as well as any workshop materials for people to follow through with if they want to kind of go through it in their own time. But please, stay on mute, but feel free to, ask some questions. I'll also be hanging out in the workshops channel if you want to type some questions in there, and I can bring those up. But now I'll hand it over to Taki and Stouffer, who are going to take us away with some subgrounds.
All right. Thank you, Forg. Well, Taji, do you want to say a word before I start, or?
No, you're good to go.
There you go. All right. So, welcome everybody to the first workshop on Subgrounds, our Python framework to query data from the graph network directly into your notebook. But first, before we get into the Subgrounds, I want to say a little bit about who we are and how we got where we are. So, Playgrounds, we're a very young organization dedicated to advancing on-chain data analytics through tooling and infrastructure. And we're really trying to essentially recreate the traditional Web 2 data analytics stack on Web 3 and to empower as many people as possible to do their own analytics. So, in the context of this workshop, what we're going to do is we're going to start with talking a bit about subgrounds and the motivations for subgrounds, why we decided to go with Python and the graph. And then we'll dive straight into subgrounds core features. So going all the way from the simplest primitives of subground called field paths, and then showing you how you can query data, and finally more advanced features like synthetic fields and querying non-subgraph APIs with subgrounds. And if we have time, we'll go over an upcoming feature, the query time series method. So a little bit about the background of Subgrounds. The project initially started under the name Mesh Engine, which was developed by Protein Labs. That's a company that Siri and I started. And over time, it has evolved into what became Subgrounds. And then when we finally joined forces with Playgrounds, we officially rebranded it to Subgrounds, which is sort of a play on words between subgraphs and playgrounds. And today, as part of the Playgrounds organization, we're offering Subgrounds powered tools to different clients in the Web3 space. So, why did we build Subgrounds? Well, it was mostly to address kind of the missing link between the graph and data science, where, on the one side, you have the graph. And for those of you who aren't familiar with the graph, it's this decentralized indexing and storage protocol that sits on top of all the other blockchains that support smart contracts. And so the graph contains this immense quantity of pre-modeled data because thanks to subgraphs, users of the graph can essentially crowdsource data models. And so it's already, you have pre-modeled data on one side, and then you have your Python data science toolkit on the other. But there was no easy way to get the data from the graph into Python. And this is where Subgrounds comes in. And the reason we chose Python as our implementation language was because, as you probably know, Python is the lingua franca of data science, especially in Web 2. And we're trying to make it so in Web 3 as well. So I'll quickly go over these slides. I talked a bit about the graph. These slides will be online for those who want to review those. Python, as I said, lingua franca of data science. And yeah, so the main idea of Subgrounds is really to develop a powerful tool, but that is minimally verbose. And you will soon see in the demo what I mean by that. And really the goal is to, in as few lines of code as possible, get the data from the graph into your notebook. So a little bit about GraphQL, which the graph is based on. So GraphQL, as opposed to REST, GraphQL, first of all, is a query language, right? So you use it to query data from a server, or in this case, the graph. And it's often used as an alternative to REST. And as opposed to REST, GraphQL allows you to essentially specify all the data you want in one single request, instead of pinging different endpoints for different types of data. And this has many advantages where you can, well, you don't have to make many requests to an API, but it comes with the problem that parsing the response data can be quite difficult, especially when the data is highly nested. And this is where Subgrounds makes this much easier. And you don't need to know that much about GraphQL to use Subgrounds. Especially, you don't need to deal with querying responses, but at the very least, you should be able to read a GraphQL schema. So basically, the type definitions of the data that you can get through the GraphQL API. Here's another slide about GraphQL versus REST. I'll skip over that. You guys can watch it, can read it afterwards. And we'll dive straight into the demo. So I have an empty folder here, and I've already set up my environment. But if you guys want to start from scratch, essentially, well, first of all, you're going to be installing Subgrounds using your favorite Python package manager. I'm using pipenv, which you can install by running this command here. I've already installed it, so I'm not going to reinstall it just now. And then, using pipenv for any other environment, you're going to be installing Subgrounds, as well as the IPY kernel package, so that you're able to run Jupyter Notebook inside VS Code. And you're going to want to specify the Python version to be 3.10. And this is important because Subgrounds requires Python 3.10 or higher. This is because we use a lot of pattern matching inside the library, which is like a new feature that was shipped with 3.10. So once you've installed Subgrounds and the kernel library, well, you can essentially just start a notebook in VS Code and start playing around with Subgrounds. And the first thing you're going to want to do is import the Subgrounds class. You're going to want to initialize it. And this object essentially will be used to, this is the main object you will be using to interact with the graph via Subgrounds. And once you have the Subgrounds object, you can start loading a subgraph. And in our demo, we're going to be using the sushi swap subgraph. The reason for that is that it's a fork of the Uniswap v2 protocol, which is probably the most forked protocol in DeFi. So, a lot of people are familiar with it, and the subgraph itself is pretty well made. So it has a lot of data we can play around with. So how you would load a subgraph is by calling the load subgraph method on the Subgrounds object, and essentially giving it as an argument the URL of the GraphQL endpoint. And if you're wondering where you get the URL, you can go on the, from the main website of the graph, you go on the products hosted service page. And then, first of all, you can see all the other subgraphs that are indexed on the hosted service. But in our particular case, it's going to be the sushi swap exchange subgraph, which down there somewhere, but I have it open here. You can find the query URL here. And this is what we'll be plugging into Subgrounds. So you copy that, plop it there, and we can run that cell. And what load subgraph does is essentially it runs the introspection query on the GraphQL API endpoint. And it generates this object here that contains all the entities and all the fields you can query on the subgraph. And so, to illustrate how that works, I'll show you how you can create GraphQL requests with Subgrounds. So the primitive that you will be using to craft Subgrounds requests is something called field paths. And a field path is essentially a selection path from the root query entity, which is present in all GraphQL APIs, all the way to a leaf that is a scalar, right? So in this case, we're starting from the sushi subgraph. We're querying the pairs field, and then the token one field, and then the symbol. And to show you what this looks like in raw GraphQL, you can run this little code snippet here. And you can see that, the field path object that we have right there, closely, matches one-to-one with this raw GraphQL query. And yeah, obviously you're going to be querying more than just, a single value. So what you can do is, using Subgrounds, you can combine multiple different field paths into the same request. So for example, here, if you want to query, the symbol of both tokens, print that out. We get a GraphQL request that includes, both selections, right? So starting from the root query, then we get the pairs, then we get both token 0 and token 1, and then the symbol of both. I think, did someone want to ask a question or something? All right. Well, I thought I heard something. Anyway.
El Terrell wanted the URL for the sushi for the endpoint for the sushi swap, and people are talking in that workshop channel. I don't know if you can see that.
Yeah, I can. Yeah, I'll copy that over. All right. Yeah, the URL is now in the workshop channel. All right, where was I? Yeah, so field paths, and obviously writing the full field path from start to end every time is kind of redundant. So you can have partial field paths as well, so that you don't have to rewrite the whole thing every time. Oops. And you can see that this query here is equivalent to this one here, except that in the first case we had the field path from start to finish, and here we're using a variable to store the partial field path and reuse part of the path essentially. If you want to add arguments to your selections, that's also something you can do with field paths. And this will be done in pure Python as well. So I'll show you how to do that. So let's say we want to get the latest 10 pairs on SushiSwap. You can add arguments to your selections by essentially opening up the parentheses and adding them here. So in this case, we're going to be ordering by timestamp, ordering in descending order, and selecting the first 10 pairs. And if we print out the raw GraphQL equivalent of this request, let's say we're going to also select token 0 symbol, like so, we can see that, well, in fact, oops, there's a typo here. Yeah, exactly. The 3 arguments were specified here on the pairs field are present in the GraphQL equivalent. And if you're wondering where I'm getting all these, the names of these arguments, that's something you can explore in the GraphQL console that is offered by the graph here. So for example, if we go to, if we try to query the pairs, we'll see that we can specify an ordering field, an ordering direction, a filter, and all these other arguments here. So it's useful to have that page open at the same time as you're using Subgrounds to query data, because then you can go back and forth and explore the different entities as well as the fields you can query on all of them. So that was, oh yeah, and you can ignore this alias here. For those of you who are familiar with GraphQL, this is essentially an alias that renames the pairs field to, well, whatever alias you want. And in this case, it's used by Subgrounds internally to do some fancy stuff. But usually you're not going to be using the raw GraphQL output of Subgrounds. You're going to be querying data directly in Subgrounds using field paths. And this is what I'm going to show you how to do just now. So the first function we'll be going over is the subgrounds.query function method. Sorry. And this is really like the simplest way you can get data from the graph in Python. And you'll notice a pattern here where like all the Subgrounds functions, they all have the same form in the sense that they all take lists of field paths as arguments. And if we want to say, here's a good one. Let's say we want to get the latest pair, right? So essentially the same query we did before, but getting only the first pair ordered by timestamp in descending order. And maybe we're interested in querying the address of that pair. While using subgrounds.query, this is very easy to do. You just plug the field path of the data you're interested in, and you get a single value. In the case where you are querying multiple fields of a single entity, so let's say we were interested in both the latest pair ID and perhaps the symbol of that pair's tokens, we essentially get a tuple with the 3 values of ID and token 0 symbol, token 1 symbol. And in the case where we are querying multiple entities, so, for example, 10 pairs, and we're querying a single field, then subgrounds.query would yield a list of values. So that would be the ID of the 10 latest pairs. And likewise, if we're querying multiple values for those 10 pairs, like for instance, the tokens, we'd get a tuple. Oops, that's not the right field path. We get a tuple of lists where the first list would be the ID of those 10 pairs. The second list would be the token 0 symbol of those 10 pairs. And then, well, the symbol of the token 1 for these 10 pairs. Well, you can probably already tell that like as the data you're querying gets larger, the query method, is not the most useful for large amounts of data, right? It's very useful when you're querying like a single value or like maybe a few of them. But for larger amounts of data, that's not what you're going to be using. Instead, you're going to be using the query data frame method, or query df. And just like the query method, this method takes as argument a list of field paths. But instead of just returning the data in a tuple of lists or in a more basic representation, it returns it in a nice data frame, where the column names are inferred from the field path itself, and the data is flattened as much as possible. And what I mean by flattening is that, as mentioned previously, sometimes when you deal with JSON data resulting from a GraphQL query, you can have highly nested, highly nested data, right? So lists inside of lists and different dictionaries inside dictionaries. So like, for example, maybe we're interested in getting the last swaps for the highest traded pairs, right? So, if we go top 10 pairs volume, we can get those pretty easily, like so. And then if we want to get the latest 10 swaps for those pairs, well, we can start from the partial field path, top 10 pairs by volume, and then just query the swaps, ordering them by the timestamp. Like this. And this request, right? We're querying a list of swaps from a list of pairs, right? So you're going to get a list inside a list in your data. And to show you what it looks like in the raw GraphQL, say we query like the ID of the pair, maybe the symbols of both tokens, and for the swaps, we'll be querying, let's say, the timestamp and the sender. So this would be the equivalent GraphQL query. And so you have, you have the list of swaps inside the list of pairs. You have, nested data here in the form of the token symbol. And this, if you were to query this manually and just get the JSON data as a result, you'd have to do a fair amount of wrangling to flatten this or transform this into useful data. But in our case, Subgrounds will do that for you. So we just use query_df, we're going to get a nice flattened data frame. And what's happening in the background is essentially the subgrounds will be doing a join between the swaps and the pairs, such that you have 10 different swaps for each pair, or essentially 100 rows. And something else to be aware of when you use query_df is that depending on what you're querying, sometimes it will be returning more than one data frame. So to illustrate this, consider the case where you would be querying both swaps and also mints from the subgraph. So maybe let's get this here. We have our last swaps. We get mints. Yeah, so in this case, since we're querying lists of different entities at the same time, let's say we do get the timestamp from the sender for the swaps, and then maybe for the mints, we get the ID and the timestamp, something like that. In this case, since we're trying to query different types of data in the same request, then Subgrounds will understand that the swaps and the mints can't be concatenated, right, and flattened to one table. So in this case, it will return 2 data frames, right? So a swap data frame and a mint data frame. If you as a list, right? So if you deconstruct the list like so, you can get the 2 data frames pretty easily. Are there any questions so far? I've been going quite fast because there's a lot of stuff to cover, but if someone wants to ask a question, feel free.
I've posted a follow me guide, basically the deck, in the workshop chat channel. Has a lot of visual representations on a lot of the topics Topher is covering here, if anyone is interested in finding that there.
Yeah, and we'll be sharing the notebook as soon as the demo is over as well. So, you guys will be able to go over the recording with the notebook and follow along.
So if you don't mind, we're going to take about a 2-minute break, and Gabriel's going to go over a quick POAP distribution for our workshop here, and then we can jump back into it.
All right. So so that was query_df, right? So essentially how you can get how you can go from the graph to a data frame in a few lines of code. The next Subgrounds feature I want to showcase is a small feature, but it's still pretty neat. So for anyone who has ever queried data from the graph, you might have realized that there is a limit to the number of entities you can query in a single query. And so, and that limit is 1,000 entities, right? So if you're interested in, say, getting historical swap data from SushiSwap, you essentially need to paginate client side and query 1,000 swaps at a time while updating some sort of cursor every time you query the data. But with Subgrounds, well, essentially Subgrounds handles that for you. So, you know, in the case where you would like to query the last 10,000 swaps ordered by, let's say, the timestamp, like so. So we get the timestamp and the sender. Why not? So essentially, yeah, Subgrounds will take care of the pagination for you in the background. And if you guys are interested in seeing how that is done under the hood, the complementary slides we've provided kind of break down like the path that a Subgrounds request takes through the system. And as you can see, we got 10,000 swaps, and we did not have to worry 1 second about the pagination. So that's pretty neat if you're interested in getting large amounts of historical data. Now let's get to something a lot more interesting, synthetic fields. So synthetic fields are kind of analogous to SQL views, for those of you who are familiar with SQL, in the sense that you can define transformations based on the schema of the subgraph. And then essentially query through these transformations as if they were regular fields. And so to illustrate how synthetic fields work, we'll be starting off with something you might encounter if you're interested in analyzing DEX data, which is the historical price of some pair. So first we're going to get the ETH USDC pair on SushiSwap, and I have the address right here. I can also probably copy that to the workshop channel. Oh, there it is. Yeah, so once we have so this is, we're selecting the single pair with that address, which is the ETH USDC pair on SushiSwap, and then we're going to be selecting the latest swaps from that pair. So for the last 10 swaps. And if you want to essentially track the price of Ether and USDC from the SushiSwap exchange using the swap data, well, looking at the swap entity on the subgraph, we can see that there's no price field in the swap entity. However, we have these 4 fields here: amount 0 in, amount 1 in, amount 0 out, and amount 1 out. And these basically show you the quantity of token 0 and token 1 that have entered or left the pool when a swap occurs. And so, there's a way to calculate the price based on these 4 fields. And how you would do that, well, I mean, first of all, you can do it, kind of like the traditional way. You can just query these 4 fields oops. Can query these 4 fields into a data frame and then do the manipulation afterwards, right? By playing around with the data frame columns. But using subgrounds and using synthetic fields, you can do something much more interesting by essentially defining the operation to get the price out of these 4 fields as a synthetic field. And so how that works is, on the swap entity, you can create a new field and assign it essentially a Python arithmetic operation that uses other fields of the swap entity. Right, so just quickly write that right now. Right, so what we're doing here is, the synthetic field price on the swap entity will be equivalent to the net amount of token 0 that has changed in the context of the swap, divided by the net amount of token 1 that has changed during the swap from the pool's point of view. And once you have defined the synthetic field here, well, you can essentially query that field, the price field, as if it were a regular field, like so. And we can see that, well, in this case, it looks like the latest price of Ether is $3,416. And so that's how you can define a synthetic field using Python arithmetic operators. But obviously, if you want to do something more complicated, that doesn't involve Python arithmetic operators, well, Subgrounds gives you a way to do that as well by using the synthetic field constructor. So we're going to import it real quick from the Subgrounds subgraph subpackage. And for this example, yeah, so okay, let's try to make the timestamp more human readable. Because right now, we have the price here. That's easy enough to understand, but a Unix timestamp is not very human friendly. So what we could do is define a synthetic field on the swap entity called datetime using the synthetic field constructor. Also import this right here. Yeah, and how you use the synthetic field constructor, it takes essentially 3 arguments, where the first argument is going to be a function that is essentially the transformation you want to do on the other fields that will be used as arguments for the synthetic field. So in this case, we're going to be applying a function to the timestamp, and we're essentially just going to format the timestamp into a nice human readable string. The second argument of the synthetic field constructor is the type of the resulting field. So in this case, datetime will be a string containing the human readable timestamp. And the third argument to the synthetic field is the field that will be used as an input to that synthetic field. So in our case, it's going to be the timestamp itself, the raw timestamp. So once that is defined, instead of querying the timestamp of the swap, you can query the datetime, which, well, much more human friendly. Something to note is that when we define synthetic fields, we're defining them on, we're using field paths that don't start from the root query entity, but instead start from the entity we're modifying itself. So, compare, this type of field path, right, where we go, it's like the timestamp of the swap, as opposed to something like, if we go back to the beginning where we start from the query and then get the pairs token 0 symbol, right? These are kind of like full field paths that start from the root of the subgraph all the way to a leaf. But when we're dealing with synthetic fields, we're only looking at the entity that we're modifying itself. So in this case, we're adding a new synthetic field to the swap entity, so we'll be using as argument the timestamp of the swap. If you want to do, if you want to create a synthetic field that uses multiple arguments, you can also do that using the constructor. So for instance, I'll show you how you can essentially rewrite that synthetic field using the constructor. And this one will take 4 arguments: amount 0 in, amount 0 out, amount 1 in, and amount 1 out. So let's call it price number 2. Let's say amount in, amount 0 out. The formula will essentially be the same. The type will be a float. And here, instead of a single field path as an argument, we'll be supplying a list of field paths that, well, correspond to the 4 values we're using in our transformation here. And it's important to make sure that, the order of the field paths in the list line up with the order of the arguments of the function. So in this case, we're starting with amount 0 in, then going to amount 0 out, and amount 1 in and amount 1 out. So if we query both the initial price synthetic field here that we define using the arithmetic operators, as well as the one that we define using the constructor, well, we'll get the same value. So they're equivalent, but you can use either way to construct this synthetic field. Something else about synthetic fields is that you can use synthetic fields as inputs to other synthetic fields. And so in a sense, you can create like a nice hierarchy of transformations, and you can also export certain synthetic fields and share them between different projects. So for instance, let's say we want to get the price in cents for some reason. We can do that by creating a new synthetic field. Let's say price cents. That will be essentially the price times 100. And voila, we can get, we now have a synthetic field, that uses another synthetic field as its input, which is pretty neat. The last topic I want to cover here when it comes to the core features of Subgrounds is, what if you want to query a GraphQL API that is not a subgraph? So for instance, the snapshot API, which is a GraphQL API, but it's not a subgraph, so it doesn't share some of the standard fields that are common to all subgraphs. Well, Subgrounds lets you do that as well. The only thing you have to change when you use a non-subgraph API is that instead of using the load subgraph method, you're going to use the load API method. So in this case, we're going to be doing a little example with the snapshot API. I'll share that URL as well. And yeah, really nothing really changes when you query a non-subgraph API, except for the automatic pagination, which will not work for non-subgraph APIs. But apart from the pagination that you'll have to do manually, everything else still works, right? So for example, the snapshot graphical API has an entity called proposal, on which there is a timestamp. So we can create a synthetic field on it, like we did for the swap. Now we're going to be using snapshot proposal, and we're getting the end timestamp. We can also query oops. And I'll show you quickly what this looks like. Yeah, so if you go straight to the API URL, you can see that they just like the sushi swap subgraph on the graph, the snapshot API also has like this nice interface where you can explore the different entities as well as the fields you can query from them, right? So in this case, we're going to be querying the proposals. We're going to be ordering them by, yeah, so in this case, since we're not dealing with a subgraph API, you can also just write the ordering field as a string. That works too. Likewise for the order direction first. And we'll be adding a filter to only query the MetricsDAO proposals, and also the proposals that are closed. So we have our proposal field path here with all the arguments we want. And then we'll just quickly write a little request. So we'll get the date time, which is the synthetic field we defined here, the title, which, if you go on the proposal entity description here, you can see that it has a title, it has all types of information you can query, and we'll get the number of votes. And as you can see, we get the data frame output we expect, just like if it was a subgraph API, but in this case, it's not a subgraph API. So that wraps up what I wanted to show you guys for the core of Subgrounds. Now, we still have 5 minutes for the hour, so I'll quickly show you a sneak peek of some upcoming Subgrounds feature. Where's my... All right, so this is my development environment. Yeah, so we're using the same subgraph here, sushi. All this should be, you'll recognize, right? We're defining the price synthetic field, daytime synthetic field, querying the swaps of the ETH USD pair, querying it as a data frame. But let's say we tried to plot the data, right, that we queried from the swaps. Let's say we're interested in the price over time. We want to display the swap price over time. I'll just update this real quick. Yeah, what you might notice if you try to do that is that, since we're getting the price information from swaps, the plot that we're going to get is pretty, well, it's not very good looking, right? Because essentially you get one data point for each timestamp at which there was a swap. And so it's not, it's not regularized. It's not very pretty. And, in case you're wondering, like, oh, how the hell did I get a plot here? This will be part of next week's workshop hosted by Tachi. He'll go through how you can visualize Subgrounds data in your notebook or even on a website. But yeah, going back to the upcoming feature I want to show you guys is query time series, which is going to be a new method of Subgrounds which will allow you to essentially go from a terrible looking chart to something that is, well, much better looking, right? That is regularized, where you get one data point per interval that you define. In this case, we're using the hour interval. You can even, define aggregation methods for each bucket, as well as how to fill the missing data for each of these hourly buckets, right? Yeah, and as you can see, we looked at the price here, but if you had tried to also plot the volume over time using the swap data, if you use the raw data, well, you get this chart that is terrible, since you do actually have volume bars, but they're only present, their width is only like 1 second, so you can't even see them from the main chart, right? But if you use the time series method, and you aggregate, you sum all the volume information for each hour, you can get a much nicer looking chart where you get actually like nice looking bars, one for each hour, which is the volume in that hour. But I don't want to spend too much time on this because this is still experimental and will be coming in a Subgrounds near you in the next few weeks. So this is pretty much what I had planned for you guys today. Is there any question, comment?
Maybe a preview of what we will be discussing next week.
Yeah, so next week, as I mentioned, Tachi will be going over the visualization component of Subgrounds. So if you guys want to take a look at what is possible with Subgrounds, oops, all of this. Yeah, so these are just some examples of charts you can build using Subgrounds. In this case here, we're plotting the own price over time, as well as the staking rewards over time. Yeah, and Tachi will also show you how you can, well, not only get visualization inside your notebook, but then build a full-on dashboard that you can deploy to the web using Dash.
Do we have that link?
Oh yeah. Sorry about that. Yeah, and so if you guys want to see what is possible when everything is put together, well, this is this was all built using Subgrounds and Dash. You can probably guess what protocol this is about, but essentially, yeah, you can get close to something you can get with Dune, but all in Python, all open source, all built on top of the graph. And in fact, here is something we had developed some time ago where we tried to replicate the Dune dashboard of Olympus using Subgrounds. And so for those of you who are familiar with Olympus, you might recognize some of these charts, but they are not from Dune. They are entirely made with data from the graph and Subgrounds. Yeah. Tachi, do you want to say something else?
Yes, thank you so much, Stouffer. Wonderful job breaking down the core of Subgrounds and kind of showcasing some of the technologies that we're building at Playgrounds Analytics. And thanks everyone for the opportunity to kind of show what we're doing. And we're looking forward to more questions. And thanks to the MetricsDAO team for having us. Next week, we will be introducing, the more visual aspect of Subgrounds. Because as we mentioned earlier, Subgrounds is, more capable than just being used in your notebook. It's developed with visualization in mind as well. So everything from tapping into the blockchain to creating highly interactive, visually stunning dashboards that you can deploy on the web. So you can have web apps powered by Subgrounds without ever leaving your Python environment. So this will be part 2 of the workshop series next week, Wednesday, same time. And I will be taking the lead on that. And how do you get from the data frames or maybe just raw Subgrounds code to generating dashboards that you can host on your own or share with your friends or your community. So looking forward to having that workshop with you, and thank you for your time. Forg, do you have any comments, any questions, everyone?
Well, this has been awesome. Thank you both for stopping by and going over this overview. I'm really excited to see next week's workshop and actually putting this together and putting together some end use products based on the data queried from the graph. Really looking forward to it. And thanks everyone for stopping by. So far, this has been our most attended workshop, which is absolutely awesome. Looking forward to keeping that momentum up and hope you all join us next week.
Thank you, everyone.
Yeah, thanks everybody. If you have questions, feel free to reach out. Maybe Tachi, you want to link the Playgrounds server?
Yes, I'll link the Playground server and I'll link the GitHub repo for Subgrounds. So if anyone wants to play around with it, and I believe Forg, maybe you already shared the Git book that has the first video in there.
Yes, and I'll update that with the recording for this, and then I believe that you said you're going to share the Jupyter notebook rather. I can add that as well as embedded, or are you just going to put that in like in your GitHub?
Okay, perfect. All right. Thank you, everyone.